Okay, so first, please write down the problem. Please write down the problem. The following sums, SUMS, the following sums were obtained from 10 sets of observations. The following sums were obtained from 10 sets of observations on cap Y, comma, cap X1 and cap X2. Capital Y, capital X1 and capital X2. The following sums were obtained from 10 set of observations on a Y, X1, X2. So what is N? What is the number of observations here?
10.
10, yes. So N is equal to 10. And the sums we have summation Y. So these are the values. Please note down these values. So we have these sums. The question is, estimate the regression of Y on X1 and X2. Estimate the regression of Y on X1 and X2. Including the intercept term. Including the intercept term. And test the hypothesis that the coefficient of X2 is 0. Test the hypothesis that coefficient of X2 is 0. So in context of test, one by one, just coefficient of X2. So I'm not considering any test combining X1, X2. Okay, so this is the problem.
Ma'am,
let's start with this. Yes, yes.
ma'am, could you repeat everything after the intercepts?
Okay, so estimate the regression of Y on X1 and X2 including an intercept term and test the hypothesis that the coefficient of X2 is 0. Test the hypothesis that the coefficient of X2 is 0.
Okay, ma'am, thank you.
Got it? So this is the problem. Hope you are understanding. Here, there are two explanatory variables. There are two explanatory variables, okay? So, first I'll write down the regression model. The regression equation is given by, So this is the structure of the regression equation. Is it all right to everybody? Is it understandable?
Yes.
We have to estimate beta naught, beta 1 and beta 2. So it will be easier first if I estimate beta 1 and beta 2 and then plug the values of beta 1 hat and beta 2 hat in relevant equation to derive beta naught. Okay, beta naught hat. So what I'll do, I'll consider the model in the deviation form. So because as long as everything remains 2 by 2, everything will be very easy for all of us. So please check if there is any problem, please ask me. Okay. So we need to find out all the values of y bar, x1 bar and x2 bar. Okay. And derive all capital sum y square, sum x1 square, sum x2 square, y x1, y x2 and x1 x2. So all these 6 values in the deviation format, So starting from this summation y square, we have to consider the values in the deviation form. Okay. So first you find out y bar, x1 bar and x2 bar and tell me the values. What will be y bar?
1, 2.
Everybody, I hope understanding. 20 by 10. Summation y is 20. Number of observation is 10. So it is 2. And what about x1 bar and x2 bar?
3 and 4.
Is it okay to all of you?
Yes.
Next, if we like to find out summation small y square, what I'll do? Anyone?
Summation yi minus y bar divided by n.
The values we have in terms of those values, would you please repeat the formula or rearrange the formula? We have summation y square. Will it not be the right formula here? Pratyush?
Yes, ma'am.
Because we have information on these things. Following the same logic, So what will be small summation yx1 in terms of the information I have? Shivani, are you here?
Yes, miss, it will be 48.2.
What will be the formula for summation yx1? Plus tell me the formula.
Oh, sorry, miss, I told the answer for the wrong question.
Yeah, just tell me what will be the formula. Summation yx1. What will be?
I'm not really sure.
Will it be this one?
Yes, miss. Yes, miss.
Okay. Orko, what will be summation yx2? Orko?
हाँ मैम
घूम থেকে উঠো বাবা। What will be summation yx2?
Ma'am, summation yx2 minus n y bar x2 bar.
Pretend sleepy.
No,
Summation x1 x2? এটা কি হবে বলো? Anyone?
Summation x1 x2 minus n x1 bar times x2 bar.
So please find out all these values. Calculate all these 6 values and one by one tell me what are the values. Olipriya,
Yes, ma'am.
what are the values? What is the first one?
Ma'am, 48.2.
48.2. Second one?
Ma'am, 2.
Only 2. Third one?
3.
Very good.
This one.
Yeah, what is this? -1. Next one?
8.
Next one?
Ma'am, yet to calculate this one actually. I'm doing it.
Ma'am, last one is -1 as well.
-1. So all these values are done. We can derive all these values. Then we will write down the normal equations. What is the structure of normal equations in context of k-variable model? Darpok?
ম্যাম কি বলছেন?
নরমাল ইকুয়েশনস গুলো কি হবে, কিভাবে লিখি? k-variable মডেলে নরমাল ইকুয়েশনস গুলো কি করে লিখি? The normal equations?
বলছি ম্যাম
অভিষেক আছো? x prime x beta hat
equal to x transpose times y.
yes, x prime x beta hat is equal to x prime y. Now what is x prime x? So what are the values I have written? Summation small x1 square, summation x1 x2, summation x2 x1, and summation x2 square. If you look at the problem, summation x1 square, that is given by 2. Summation x2 square, that is given by 3. Summation x1 x2, that is given by -1. So x prime x matrix can be written as 2 -1 -1 3. Is it okay? এখানে হবে summation yx1 আর summation yx2. So what I have done, x prime x, that is summation x1 square, summation x1 x2, summation x2 x1 or x1 x2, whatever, because it is symmetric, and summation x2 square. That will be multiplied with beta 1 hat and beta 2 hat to gradient terms. And that is equal to x prime y. That also we have to take in the deviation form. So the values will be -1 and 8. If anyone have any confusion, please ask me.
ম্যাম এক্স ম্যাট্রিক্সটা কলাম ম্যাট্রিক্স তো
X matrix column matrix হবে, দুটো এক্সপ্লিসিটলি ভেরিয়েবল আছে তো x1 x2, তাহলে
হ্যাঁ
ট্রান্সপোজটা হচ্ছে একটা রো ভেক্টর x1 x2, এরকম
হ্যাঁ
তো।
ট্রান্সপোজটা রো ভেক্টর আর এক্সটা কলাম ভেক্টর তো
আর এগুলো তো ভেক্টর মানে কি, এগুলো তো অবজারভেশনস।
হ্যাঁ
x1 আর x2 এগুলো তো অবজারভেশনস। So x itself is a matrix. Matrix formulation রয়েছে না।
আমি বলছিলাম যে এক্স ম্যাট্রিক্সটা ওটা 2x1 হবে কিনা বলছি।
এক্সটা এরকম, ঠিক আছে।
ও আচ্ছা, ইয়েস।
এইরকম, ঠিক আছে। তাহলে ওর ট্রান্সপোজটা নিলে 2/n multiplied with n/2 will give us 2/2, ঠিক আছে। তারপর
হ্যাঁ
x looks like this, যতগুলো এক্সপ্লানেটরি ভেরিয়েবলস থাকবে পরপর লিখে নেবে আর ওর অবজারভেশনস গুলো বসাতে থাকবে। ওকে, মানে অবজারভেশনস গুলো কলাম ওয়াইজ আসবে আর ভেরিয়েবলস গুলো সাইড বাই সাইড যাবে, মানে রো ওয়াইজ যাবে। আচ্ছা, সো We can do it in two ways, as long as it is a 2 by 2 matrix. X prime X is a 2 by 2 matrix. We can do it in two ways. So what I can do, I can form two equations. I can use matrix multiplication, that is 2 beta 1 hat minus beta 2 hat is equal to minus 1. That is one equation. And minus beta 1 hat plus 3 beta 2 hat is equal to 8 is another equation. Simultaneously solving these two equations, I'll be able to find out beta 1 hat and beta 2 hat. Alternatively, I can use the formula beta hat is equal to x prime x inverse x prime y. So in that case, I have to take inverse of the matrix 2 minus 1 minus 1 3, and that I'll multiply with x prime y, that is that column vector, minus 1 and 8. So as long as I have a 2 by 2 structure, if you have more, in that case also, you can consider the equation and simultaneously solve the equation. However, better will be to consider the inverse. That will be easier. So in this case, you can follow either of the two ways. So what you can do, you can write down two equations. And another one is so solving these two equations, you will be able to find out beta 1 hat and beta 2 hat. Would you please solve two equations and tell me what are the values of beta 1 hat and beta 2 hat?
Beta 1 hat is minus 2 and beta 2 hat is 3.
Beta 1 hat is beta 1 hat is
Minus 2.
minus 2.
हाँ.
চেক করবে?
আচ্ছা আমি একবার দেখছি তাহলে.
Miss beta 1 hat is 1.
Ma'am, beta 2 hat is minus
2 hat is 3.
Beta 2
Beta
hat
1 hat is and beta 1 hat is 1.
দেখি এবার একটু লিখি। এটা বলছো বিটা 1
হ্যাঁ
hat
ম্যাম।
ওকে, তাহলে শ্রেয়া একটু চেক করলে?
ম্যাম বিটা 2 হ্যাটটা ঠিকই এসছে আমার, আমি বিটা 1টা দেখছি।
হ্যাঁ, বাকিরা সবাই এই ভ্যালুস গুলো বেরোচ্ছে?
হ্যাঁ ম্যাম পেয়ে গেছি, ওটা 1 হবে।
1 হবে তো?
হ্যাঁ হ্যাঁ সরি।
1 আর 3 লক্ষদ্বীপ বেরোচ্ছে?
ইয়েস ম্যাম, হয়ে ওটাই বেরিয়েছে। বিটা 1 হচ্ছে 1 আর বিটা 2 3।
1 আর 3, আচ্ছা। তাহলে দিস ইজ দ্য রেজাল্ট। এবার একটু দেখা যাক এটা অন্য কিভাবে করতে পারতাম। বিটা নট হ্যাট এখনো বের করিনি, ইন্টারসেপ্ট টার্ম এখনো বার করিনি। সো একটু দেখা যাক। Should I erase this slide? Everyone could complete it. X prime x is equal to so we will like to calculate x prime x inverse because I'll use the formula This is the vector. Okay, so this is x prime x. So let's first check the determinant. Please take the determinant and tell me what is the value. Is it 0 or non-zero?
Ma'am, it's
Ma'am,
7.
it's 5. 1 0.
7 or 5? 6
Sorry,
plus
5.
6
5.
minus 5.
5.
6 minus 1. So we can take the inverse of this matrix. Okay. Adjoint by determinant. Now tell me what will be the adjoint? What will be the first component?
Ma'am, 3.
হ্যাঁ ঠিক আছে
3, তাই তো?
Yes, ma'am.
এই রোটা বাদ, এই কলামটা বাদ, এই রোটা বাদ, so 3. What will be row wise second element?
Plus 1.
1
1. Second row,
-1
minus 1.
না
No, ma'am,
1
1.
1.
Next element,
2.
2.
এটা transpose.
এটা ট্রান্সপোজ কেন?
ম্যাম ট্রান্সপোজ নিতে হয় তো অ্যাডজয়েন্টে কোফ্যাক্টর গুলো বার
হ্যাঁ,
করে
এটা
মাইনর গুলো বার করে ওটা ট্রান্সপোজ। অ্যাকচুয়ালি এখানে ডিফারেন্স হবে না বিকজ দিস ইজ সিমেট্রিক।
ডিফারেন্স হচ্ছে নাকি? ঠিক আছে, ট্রান্সপোজ নাও, এটাই আসছে। Yes, you need to take the transpose, however, the same thing is appearing. ঠিক আছে তাহলে? আচ্ছা, তাহলে এবারে আমি বিটা হ্যাটটা করব। What is x prime y?
-1 8.
So please solve it and check whether you are getting the earlier values or not.
Yes, ma'am, same values.
Same value?
yes ma'am
Okay, so we are getting the same value. So this is the beta hat vector, where beta 1 hat is equal to 1 and beta 2 hat is equal to 3. So in this way, using matrix algebra, also we can solve for the values. So simultaneously solving the equations, you may find out the value. Alternatively, applying the technique of matrix algebra, you will be able to find out the values. Anyone, any question, any problem? So what I mentioned, you can use the normal equations, solving simultaneously the normal equations, you can find out the values, or you can use the inversion. First you have to check the determinant and then you can go for inversion. Then also you will get the same value. Next, intercept. To find out intercept, we will use the formula. Okay. Beta naught hat is equal to y bar minus beta hat transpose x bar. What is y bar?
2.
Beta hat transpose. What is x1 bar? Actually, this will be what are the values? Solve this value. Once you get the value, please tell me what will be the.
Ma'am, negative 13.
I'm minus 13.
Are you understanding the logic or the principle by which we are deriving the intercept here? In case of two variable analysis, what was the formula for alpha hat? Y bar minus beta hat x bar. Now here we have a series of beta hat and a series of x bar. So we have to consider beta hat transpose x bar. Y bar is a scalar, a single element. Now what is the order of beta hat prime? What is the order of, if beta is of order k by 1, beta hat prime will be of order 1 by k. Okay, 1 by k. So here 1 by 2. Okay, and this is 2 by 1. So this multiplication will make it a scalar. And we will be able to take the difference from a single element y bar. Okay, so we have to create a scalar using all beta hat values and all x bar values. So we are exactly doing that. So this is the formula for calculating intercept in a k variable analysis. It is y bar minus beta hat x bar, beta hat prime x bar. Any question, query, any part which I need to repeat?
Ma'am,
Yes.
Ma'am, yesterday you told us that x transpose times x times beta hat equals x transpose times y. That yields a set of k normal equations. Right. So, ma'am, so if we solve these normal equations, the first
Yes.
equation will be similar to the CLRM equation, right? Y bar equals alpha hat plus beta hat x.
Aratvi, we did this thing. The alternative way I discussed in that way. We are considering the set of normal equations, and using the normal equations, we estimated the value of beta hat. Just before coming to these steps, that is just before coming to the idea of how I'll take the inverse, I'll do the thing. I just discussed that part, isn't it?
Yes, ma'am. Okay, I see. Got it, ma'am.
Okay. So actually, using the deviation form, we can write down the normal equations. We can find out all beta hat in gradients. Then using this formula, I'll be able to find out the beta naught hat. Okay, so this is the standard way. Let's first consider the deviation form. Use either of the two methods. Either you consider x prime x inverse x prime y to calculate all the gradient terms, or you use the normal equations x prime x beta hat is equal to x prime y. The method just we followed before coming to this particular presentation. Anyone, any other problem, anything which I need to clarify once again? So in that case, what will be the estimated equation? Hence the Hence, the estimated model is given by, what will be the model? Yi. Then what is beta 1 hat? 1.
Next one.
So this is the estimated regression model. This is basically Yi hat. Clear? Next, I told you to check the significance of beta 2 hat. Okay, check the significance of beta 2 hat. Now the second part was test the hypothesis that beta 2 is equal to 0. So what is the standard formula to test this hypothesis? How we test this hypothesis? In case of
beta 2
two,
hat
you
beta 2
learn
hat by standard error of beta.
beta 2 hat by standard error of beta 2 hat, and ওটার ডিস্ট্রিবিউশনটা কি লক্ষ্য দে? tau t chi square f.
MT.
Very good. So we have to derive So what we have to do, we have to calculate the variance of beta 2 hat. Otherwise, we will be not able to derive it. Beta 2 hat is with us, that is 3. However, we have no information at this moment on standard error of beta 2 hat. So we have to calculate the variance covariance matrix of beta. Variance covariance matrix of beta, isn't it? Now, what is the formula for variance of beta hat? We will get the entire variance covariance matrix. What is the formula?
Sigma u squared times x transpose times x inverse.
This one. Yesterday we derived variance of beta hat is equal to sigma u square x prime x inverse. Okay. Now, in absence of sigma u square, what we do?
Now we use su squared.
Okay, so please note down, in absence of which is RSS by n minus k. Okay, in case of two variable analysis, it was RSS by n minus 2. Here, it will be RSS by n minus k. Actually, when we derived the unbiased estimator for SU square, we showed that it is RSS by degrees of freedom. So whatever degrees of freedom you have, that will be there in n minus k. So k may be 2, k may be 3, 4, whatever. Okay, so we will consider in this way. So k K is the number of parameters to be estimated. K is the number of parameters to be estimated. Okay. So what we are finding that we have to calculate RSS then. Okay. We have to calculate RSS. Without RSS, we will be not able to find out the value of SU square. And without the value of SU square, we will be not able to find out variance of beta hat. And without variance of beta hat, I'll be not able to calculate T. So three things I need to estimate. First of all, SU square, and then substituting this value in the variance of beta hat formula, I have to find out sigma u square x prime x inverse. So I'll get the variance of beta 2 hat. Once we get variance of beta 2 hat, we need to use square root of this to calculate the T statistic. So three steps I need to complete to derive the value of the T statistic. So let's do it one by one. So first, what will be the formula for RSS?
The expanded one.
In case of K variable analysis?
It's generally E transpose times E.
Yes. And if I expand it in terms of the model, we present it
Then
of the model.
then it's Y transpose times Y minus 2Y transpose times X times beta hat minus
This
beta
Y
hat.
prime Y, that is the TSS part, minus this. This is the ESS part, where okay. So everybody please note down. TSS is Y prime Y in case of K variable analysis, and ESS is Y prime X beta hat. So RSS is given by the formula Y prime Y minus Y prime X beta hat. So given these facts, RSS is equal to Y prime Y minus Y prime X beta hat. Would you please derive the value of RSS here? You use the deviation form. There is no problem if we use the deviation form. Y prime Y is equivalent to what? Y prime Y is equivalent to what? Somebody has
Y squared.
summation?
Y squared.
Summation yi square. Yes, somebody had some question. Would you please ask your question?
Ma'am, I had a question. Isn't there another scalar part in that RSS expression?
Given the
Ma'am, isn't there a scalar part in that RSS equation?
RSS is totally scalar?
No, ma'am. Like apart from the two terms.
No, it is TSS minus ESS. I am using that formula. RSS is TSS minus ESS.
Okay, ma'am.
Okay. দেখো আগে তোমার টু ভেরিয়েবলে ইএসএস এর ফর্মুলা কি ছিল? বিটা হ্যাট সামেশন xi yi। তো সেরকম ফর্মুলাই আমরা ইউজ করেছি। ইন টার্মস অফ ম্যাট্রিক্স অ্যালজেব্রা we have to write it as y prime x beta hat. Okay, so in k variable analysis, TSS is given by y prime y, whereas ESS is given by y prime x beta hat. Now y prime y is equivalent to summation yi square. Okay. So this is okay, summation small yi square. So if I calculate RSS, summation yi square, what was the value for summation yi square? 48.2, I think.
Yes, ma'am.
Minus y prime x beta hat. So how I'll get it? This is equivalent to beta 1 hat summation x1y plus beta 2 hat summation x2y. Y prime x beta hat is equivalent to beta 1 hat summation x1y plus beta 2 hat summation x2y. So I'm putting these values there. Okay. So once the values are there, would you please tell me what will be the value? Beta 1 hat, beta 2 hat, everything you know. Summation x1y, summation x2y, all these things you know.
ম্যাম মাইনাস 274.8
একটু ভুল হচ্ছে জানো, তুমি খালি আরএসএস বলছো?
হ্যাঁ আরএসএস আপনি যেটা লিখেছেন ওটাই
আরএসএস ইজ ইকুয়াল টু কত বলছো?
মাইনাস
মাইনাস তো হবে
274.8
না, সাম অফ স্কোয়ারস তো আর মাইনাস হবে না, না
সেটা তো হবে না তাহলে
ভুল হচ্ছে দেখো।
হ্যাঁ
Ma'am,
ম্যাম 25.2 হচ্ছে।
25.2 হচ্ছে, 25.2 হচ্ছে ভ্যালুটা। বাকি আরো কেউ দেখবে 25.2 আসছে?
Yes, miss, it's 25.2.
Very good. So first partটা হলো RSS calculation. It is 25.2. So what is n minus k?
7.
7. Is it right?
Yes, miss.
Yes, ma'am.
Okay. 10 minus 3. So what is the value? Please check whether it is 3.6 or not.
Yes, Miss, it's 3.6.
3.6. Instead of sigma u square, I am writing SU square.
ম্যাম আরএসএস 25.2 পেয়ে গেছি, আমি ভ্যালু ভুল বসিয়েছিলাম।
ভেরি গুড শ্রেয়া। আচ্ছা, এবার এক্স প্রাইম এক্স ইনভার্স এর ভ্যালু গুলো বলো তো, চারটে ভ্যালু। এটা অলরেডি ক্যালকুলেট করা আছে তোমাদের, কেউ একটা বলো।
হ্যাঁ, এটা কত জানো? হ্যাঁ, 1/5।
ফার্স্ট একটা 1/5,
না না, 3 1 1 2
3/5,
1/5,
হ্যাঁ,
আবার 1/5, 2/5।
ভেরি গুড। So if I solve this thing, I'll get the variance covariance matrix for beta hat, as I discussed last day. So I'll be not able to calculate variance of beta 1 hat, variance of beta 2 hat, covariance beta 1 hat, beta 2 hat separately. Whenever I'll go for calculating variance of beta hat, I'll get the entire variance covariance matrix. Okay, so if we solve this one, we will get the value okay. So on this, anyone? Yes, any problem? Among all these, I need standard error of beta 2 hat only, because I am setting the t statistic for beta 2. So my null hypothesis was what was the value of beta 2 hat?
3.
3.
Oh, sorry, 0. Yeah.
0.
3. Sorry, I got confused with beta.
Okay, so this will be our estimated t. So what we are doing, just same thing we did in case of two variable analysis. Only several formulation is there. Here we have used the formula for appropriate formula for TSS and ESS. Got RSS, then RSS by n minus k is giving SU square. Variance of beta hat, therefore we will rewrite as SU square x prime x inverse. We will put the value of SU square, put the values for x prime x inverse, and calculate variance covariance matrix of beta hat. Among these, depending on the requirement, I'll select the relevant variance, will take its standard error, and then in the T formula, we will plug this and find out the estimated value of the T statistic. Now this we can compare. Nothing was mentioned about the alternative hypothesis. So you can consider the one-tail test, you can consider the two-tail test, etc. Nothing is mentioned about the level of significance. So I'll consider the 5% level of significance, the standard norm, 5% level of significance. The test will be conducted using 5% level of significance. Okay. So I can consider the one-tail test, or I can consider the two-tail test and compare this value with the tabular value. Okay. So if I consider two-tail test, that is the alternative hypothesis is not equal to 0. In that case, the tabular value with which I'll compare, that is T7 0.025.
Yeah.
So would anyone tell me what is the value for T7 0.025?
2.365.
2.365. Estimated T is greater than tabular value. So what we will do? So in this way we will proceed. In this way we will proceed. So today I mentioned about the elements in the ANOVA table while I am discussing the numerical exercise, I mentioned about the elements in the ANOVA table. Okay, so some part of the theory is also covered while I did this numerical exercise. So once again, I'll like to write down, okay, so this is equivalent to what is the formula I mentioned? ESS is equal to বলো কি বললাম ফর্মুলাটা?
Y transpose times
Y
X times
transpose
beta hat.
X beta hat. This is the formula for ESS, and this is equivalent to Okay, this is equivalent to this, or you can use the formulation for matrix algebra, whatever you like.
ম্যাম
Yes.
আপনি কি ডিভিয়েশন ফর্মেতে লিখেছেন বলে ইকুইভ্যালেন্ট চিহ্নটা দিয়েছেন?
Hi, this is equivalent to, yes.
আচ্ছা,
And RSS, naturally, okay, so remember all these formula, three formula, y prime y prime x beta hat, and RSS will be naturally y prime y minus y prime x beta hat. Any questions so far? The way we are deriving variance covariance matrix of beta hat. So in some other question, you may have this one, calculate variance covariance matrix of beta hat, or calculate variance of beta 1 hat, beta 2 hat, or calculate covariance beta 1 hat, beta 2 hat. So in that case, you have to stop with the variance covariance matrix. You don't need to proceed for, the T statistic. So would you please add one more part here? Derive the value of capital R square. Derive the value of capital R square. What is the formula for R square?
ESS by TSS.
So will you be able to find out the R square value then?
Yes, ma'am.
So here we know the value for ESS, the value for TSS, and if we plug the values here, we will get the value of R square. Would you please calculate and tell me what will be the value of R square here? Already you have TSS and ESS with you. So would you please use those things and tell me what will be the value of R square?
Ma'am, 0.95.
I didn't calculate it. Here is telling 0.95, is it right?
It's 0.477.
0.277,
477.
0.477.
Yes, ma'am.
So a lot of differences. So we need some other students.
Ma'am, 0.477.
শ্রেয়া দেখো তোমার একটু সিলি মিস্টেক
আবার ভুল। আচ্ছা দেখছি।
করছো ভালোই, কিন্তু ভ্যালু গুলো একটু ভুল হচ্ছে।
ম্যাম ওই ক্যাপিটাল আর স্মল গুলো আমি গুলিয়ে ফেলছি, আমি এটা আরেকবার দেখে আপনাকে বলছি।
Ma'am, 0.78.
0.478,
মানে অ্যাপ্রক্সিমেট করে আর কি।
হ্যাঁ ঠিক আছে, তার মানে এইটাই, এই ভ্যালুটা আর কি 0.48 টাইপের ভ্যালু আসছে।
Yes, ma'am.
So this is the value for R square.
হ্যাঁ ম্যাম ঠিক আছে এবার করেছি।
ম্যাম
ইয়েস বলো।
ম্যাম এখানে অ্যাডজাস্টেড আর স্কোয়ার ভ্যালুটাও একই হবে না?
অ্যাডজাস্টেড আর স্কোয়ারের কথা তো এখনো বলিনি, তাই কি করে বলি অ্যাডজাস্টেড আর স্কোয়ার কি হবে। এবার বলবো অ্যাডজাস্টেড আর স্কোয়ারের কথা। I didn't mention anything about adjusted R square. Let me first mention about this and then we will come back. আচ্ছা এইটা অবধি যারা করছো তাদের হলো?
Yes, ma'am.
Only 20 students are trained. বর্ষা তোমার এগোচ্ছে?
ইয়েস ম্যাম।
হয়েছে ভ্যালুস গুলো বেরিয়েছে?
হ্যাঁ ম্যাম বেরোচ্ছে।
আচ্ছা রাতুল?
হ্যাঁ ম্যাম করছি।
হচ্ছে মানে কিছুগুলো পেরেছো করতে, কয়েকটা বেরিয়েছে?
হ্যাঁ ম্যাম প্রথম দিকে পারছিলাম, একটু ল্যাগ করে গেছে, আমি বোঝার চেষ্টা করছি ম্যাম।
আচ্ছা আচ্ছা ভেরি গুড। রূপশ্রী?
হ্যাঁ ম্যাম।
সব ভ্যালুস গুলো বেরোচ্ছে ঠিকঠাক?
হ্যাঁ ম্যাম।
বোঝা গেছে কোথাও অসুবিধা রয়েছে মাঝখানে?
না বুঝেছি।
আচ্ছা সম্ভব?
Yes, ma'am.
ভ্যালু বেরোচ্ছে সবকিছু?
হ্যাঁ ম্যাম।
তোমরা বুঝতে পারোনি এরকম জায়গা রয়েছে?
না ম্যাম।
সোমদুতি? সোমদুতি করা যাচ্ছে, মানে সাথে সাথে করতে পারছো?
ম্যাম হ্যাঁ মোটামুটি।
মোটামুটি কত অবধি এগিয়েছে বলো? মানে শুধু দেখো না, মানে করতে করতে যাও। সুষমা?
হ্যাঁ ম্যাম।
হচ্ছে অঙ্কগুলো বোঝা যাচ্ছে কি?
হ্যাঁ ম্যাম বুঝতে পেরেছি, আমি লাস্ট অব্দি আপনি যতটা করলেন আমি করতে পেরেছি।
ভেরি গুড। ইয়াশ?
Yes, ma'am. I've completed the work.
ভেরি গুড। শ্রেয়া? শ্রেয়া মন্ডল? শ্রেয়া?
হ্যাঁ ম্যাম।
অঙ্কগুলো দেখছো, করতে পারছো?
হ্যাঁ হ্যাঁ।
কোথাও অসুবিধা হলে জিজ্ঞাসা করো। ঋতনু? সব বুঝতে পারছো? Good. Okay, so mostly the k variable things are done. I mentioned, again I'll talk about the correlations etc. I clarified the ideas of correlations in context of two variable analysis. I gave a note, I added a note. So once again, I'd like to mention a few points. Okay. So there are, just a minute. There are three types of R. And all these three types are very important in context of k-variable analysis because each of the correlation will have a new indication. Okay, each of the correlation will have a new indication. So simple correlation, these are the three types of correlations we are talking about. In case of simple correlation, we consider the notation small r, and it can be correlation between all explanatory variables, or it can be correlation between y and all explanatory variables, it can be correlation between a few variables, not all, you can consider y and several x variables, or say x2, x3. So it can be anything. It can be considered between two variables, two explanatory variables, dependent and independent variables. You can consider the simple correlation among the variables that are present in your model. Among these simple correlations, the most important simple correlation is this one. This one. That is the correlation among the explanatory variables. One of the assumptions of the k-variable model is there should not be any correlation among the columns of X matrix. In other words, X should have full column rank. X should have full column rank or rank of this implies, whatever be the thing, this implies okay. So in that case, okay. However, This is referred to as problem of multicollinearity. This is referred to as the problem of multicollinearity. So this is all about the simple correlation. This is correlation among all variables, a few variables, a subset of variables, whatever. Among all possibilities, this one is most important, correlation among all explanatory variables, because this is give us some idea about whether the model suffers from multicollinearity or not. The second concept is partial correlation.
ম্যাম
Yes.
আমি বলছি একটা জিনিস যে ওই যেগুলোর মধ্যে কোরিলেশন হবে সেইটাকে একসাথে লিখতে হয় আর বাকিটাকে কমা দিয়ে লিখতে হয়, মানে এরকম কিছু?
সিম্পলে তো সেরকম কিছু না,
আচ্ছা
সিম্পলে তো সবগুলোই একসাথে লিখি।
আচ্ছা, ইয়েস,
ঠিক আছে। নাও পার্শিয়াল কোরিলেশন, তুমি যেটা বলছো তুমি বোধহয় পার্শিয়াল কোরিলেশনটা মিন করছো।
না ম্যাম, আপনি এই প্রথম যেটা লিখেছেন সিম্পলটা, ওইটা কমা দিয়ে লিখেছেন বলে মনে হয়।
আচ্ছা, না সবগুলোই মিন।
আচ্ছা, ইয়েস।
Partial correlation. yx1 dot or all these things. So I am taking y and one of the explanatory variables given the rest. In the first example, I am taking x1. In the second example, I am taking x2. In the first example, x2, x3 up to xk are given. In the second example, x1 and x3 to xk are given. So in this way, we present the partial correlation. It is the correlation among y and one of the explanatory variables given the rest. Okay, it is the correlation and one of the explanatory variable given the rest. Okay, so the first will be related to beta 1 hat. The second will be related to beta 2 hat and so on. If I consider R, Y, X, K dot X1, X2, X3 up to Xk minus 1, that will be related to beta K hat. Okay. So each of the partial correlation coefficient, because it is associated with the typical explanatory variables given the rest. So each of the beta coefficient is associated with the partial correlation concept. Yx1 given x2 to xk or yx2 given x1, x3 to xk. So all these things. Next is multiple correlation. Actually, it is. It is the impact of all explanatory variables on y. How all explanatory variables together can explain y. This is the concept. And therefore, it is measured by ESS by TSS. Any question up to this? Any clarificatory question up to this? Is it okay?
Ma'am.
Yes.
So ry xk dot x1 x2 up to xk minus 1, that will be related to beta k hat.
Beta k hat, yes.
Right. Okay, ma'am.
Okay.
Ma'am.
Yes.
Oh, okay.
Bolo.
Yeah. Last line I want to note down. Okay, ma'am. Yes.
Now, R square is equal to ESS by TSS. Therefore, is it okay? Please look at the line. If any confusion is there, please ask me. Okay. So what I am telling that R square is equal to ESS by TSS. So as we incorporate one more explanatory variable in the model, ESS will improve and that will increase the value of R square. So R square takes care of this aspect. However, as we incorporate one more explanatory variable, the number of parameters to be estimated, that will also increase by 1. Given the number of observations, that is n fixed, if k continuously increases, that in turn will reduce the degrees of freedom. So R square is only an incomplete measure of goodness of fit. R square as a measure of goodness of fit can capture the aspect that as we incorporate a new variable, ESS will increase and thereby R square will increase or R square will improve. However, it fails to capture the part that as we incorporate a new explanatory variable in our model, we lose the degrees of freedom. We lose the degrees of freedom. So, this aspect is missed here. So R square in case of multiple regression should not be considered as a good measure of goodness of fit. We need to develop another concept which will be able to take care of both the aspects. That is, as the number of explanatory variable increases, the goodness of fit improves, and as we increase the number of explanatory variables, simultaneously the degrees of freedom that falls. So combining these two aspects, we will develop the notion of adjusted R square, R bar square, where both ESS and TSS will be deflated by their respective degrees of freedom. ESS and TSS will be deflated by their respective degrees of freedom. Okay? So, hence, okay, and it is defined as what is the degrees of freedom of ESS and what is the degrees of freedom of TSS?
N minus.
In practical 2, this thing.
N minus k, N minus k.
বুঝলাম না, ESS এর degrees of freedom?
N minus k.
N minus k. তাহলে RSS এর degrees of freedom কি? ESS এর degrees of freedom হচ্ছে k minus 1. তোমার explanatory variables গুলো যা আছে -1, তোমার basically k minus 1 number of explanatory variables will be there along with k minus 1 number of gradient coefficients, and another coefficient will be the intercept coefficient. Variable wise, if you consider, there will be k minus 1 number of explanatory variable and another variable is y. In a two variable model, x is the explanatory, y is the explained. In a k variable model, there will be k minus 1 number of explanatory variables and one explained variable. Okay, so the degrees of freedom of ESS, the explanatory part, will be only k minus 1. And what is the degrees of freedom of TSS? Actually, it will be the sum of degrees of freedom of ESS plus RSS. Now, the degrees of freedom of ESS is k minus 1. This is for ESS. And that for RSS is in minus k. So, if you add these two degrees of freedom, you are getting okay. So, the degrees of freedom of TSS is n minus 1. We are getting these degrees of freedom adding the degrees of freedom of ESS and RSS. For RSS, the degrees of freedom is n minus k. For ESS, the degrees of freedom is k minus 1. Because we have k minus 1 number of explanatory variables. So explanation part or explained sum of squares part will be developed from those explanatory variables. Anyone, any question? Yes. Yes. Anyone else? Any question?
Do we obtain this from the additive property of the chi-square distribution?
কি বললে শুনতে পাইনি, বলো আরেকবার। ভালো করে বলো, শুনতে পাওয়া যায় না, তোমার অডিওটা একদম ভালো নয়।
ম্যাম শুনতে পাচ্ছেন এবার?
হ্যাঁ।
ম্যাম বলছি, does this arise from the additive property of the chi-square distribution?
No. Why? We will go to the chi-square property and we will talk about this. Chi-square is the distributional aspect of ESS and RSS. So degrees of freedom, you know, that will be defined by the number of variables, number of parameters, those we are considering in the model. So from chi-square, it will be not derived. Chi-square, the degrees of freedom for the chi-square will be defined from this aspect. The reverse. Okay. Any other question? Any other thing? Okay, so I'll stop here. So check all these things. I discussed the numerical exercise, ANOVA, the measure of goodness of fit in context of k variable model. More or less the things are done. Now you have to go through these things and you have to check the matters, and if you have any confusion, any query, then you need to clarify all these things.